Good morning, one and all. So today I am going to explain the refrigeration test rig. Okay. So what you are seeing in the video, it is the refrigeration test rig. Before that, first I used to tell what are the important components in the refrigeration test rig. Okay. So first you see here it is compressor. In the compressor, as I said, the vapor refrigerant gets compressed, pressure and temperature increases. Next, so we are having the condenser. So as I said, in the condenser, the temperature decreases. So there will be a change in phase from vapor to liquid in case of condenser. Okay. Next, from the condenser, as I said, it enters into the expansion wall. You can see the wall here, wall position, the expansion wall and capillary open. Okay. So the capillary expansion wall are used to reduce the pressure of the refrigerant to the practical limits. As I said, there are two options here. One time we can open the capillary open. You can see the switch here. So in the next setup, we are going to change expansion wall. So the liquid refrigerant from the condenser enters into your the expansion wall. So where the pressure gets reduced, because so we have to supply the low pressure liquid refrigerant to the evaporator. Okay. Next, as I said, you can see the cabin here. So in the cabin, so we are having the evaporator coil. When the liquid refrigerant from the expansion wall enters into the cabinet, where it absorbs the heat from the cabinet, thereby changing the phase from liquid to vapor refrigerant. This is how the circuit works in the vapor compression test rig. You remember, it is vapor compression test rig because we are having the compression process happens in the compressor. Okay. Next, you see the pressure gauges. We are observing two pressure gauges. That is, and you remember the whatever units are in the pressure gauge are in PSI, that is pounds per square inch. And one more thing you can observe, even you are getting the readings in mm of Hg. Okay. So you have to convert that mm of Hg into the bar. Okay. So these are the four important components plus two pressure gauges to know the pressure P1 and P2. Okay. And here in this setup, now capillary valve is open. Okay. So you can see the energy meter. Okay. So energy meter, it is revolving to know how much power is supplied to run the compressor. And we are going to take the readings for 5 revolution and energy meter constant is 750. Okay. And next, because we are going to find out per ton of refrigeration, how much power is required per ton of refrigeration. For that purpose, we need the energy meter. You see the temperature knobs. Okay. So we are having the 5 temperature. Okay. T1 gives the compressor inlet temperature and T2 gives the compressor outlet temperature, 3 is condenser outlet temperature, and then T4 after expansion process, and T5 is your freezer temperature. Okay. So you can see the knob. So by pressing T1, so you can change T1. So you see 28.1 is T1 degree Celsius. Okay. Next, it is nothing but your compressor inlet temperature 28.2. Next, how to take T2? Just you change the knob. Sorry, T2, T1 is 25. So 25.6 is your T1 degree Celsius. Next, T2, just you change the knob. 28.2 0.1 is T2, that is compressor outlet temperature. You see, when the refrigerant passes into the compressor, there will be increase in the temperature. So you observe T1 is 25.5 and T2 is 28.1 degrees Celsius. Means when it passes into the compressor, the temperature increases. Next, you can see the T3 value. T3 is what? The condenser outlet temperature. Okay. Next, we are having T4. T4 is, you see, always we are getting after expansion process, the temperature decreases. You are getting the temperature in negative value. Okay, that is the after expansion process. Okay, next T5 is just you change the, now we are having 1, 2, 3, 4, 5, and T5 is your freezer temperature or evaporator temperature. Like that, you have to take the temperature. Okay, and after that, our aim is to calculate COP of the refrigerator. Okay. Okay. So this is what actually the procedure, tabular column and pH diagram of refrigerant 1 to 2. We are using the refrigerant 1 to 2 in this circuit. That is, refrigerant is a carrier substance which is used in the refrigeration system, which undergoes the change of phase from liquid to vapor in the evaporator and from vapor to liquid in the condenser. Okay, that is a refrigerant. And you remember, refrigerant used in this system is R12. And what you are observing in the chart indicates the procedure followed. And tabular column, you are going to take 5 readings, T1 to T5, P1 and P2. Okay, and as I said, there will be conversion factor from PSI to bar and also inch to bar in the yesterday's demo class. Okay, next you have to calculate H1, H2, H3 and H4. Okay, using the chart. Okay, here first you have to find out whatever at temperature T1 and P1, you have to find out H1. Okay, and next, using the constant entropy line in the HS diagram, you have to find out the H2. Okay, this is a compressor. Next, 2 to 3 is your the condensation process. So you have to, what is the temperature T3? You have to note down the readings corresponding to that T3. So you have to calculate the H3. Okay, you have to refer pH diagram for this one. Next, we have to find out you remember H3 and H4 are same because it is asymptotic process. Okay, and using the formula, coefficient of performance can be calculated by H1 minus H4 divided by H2 minus H1. Next, one more calculation is there to calculate HP per ton of refrigeration. As I said, power input to the compressor. You can see the energy meter constant here. Okay, and we have to note down how much time is taken for 5 revolutions of energy meter. Okay, once you note down that value, so you are going to calculate the power input to the compressor. Okay, that is the formula, and divided by 3.5 because 1 ton of refrigeration equals to 3.5 kilowatts, like that. So first you analyze all the components, then you have to take the readings properly, and you have to use refrigeration 1 to 2 chart. Using that one, you are going to find out H1 and H2, and finally we are going to calculate the value of coefficient of performance. So you remember, coefficient of performance, what we are getting is above 1. Okay,